Yeah, the topic we have here is reinforcement in construction. So, because in most of our construction work, whereby we use concrete, we always make use of reinforcement. So, we want to actually understand, the reasons why we make use of reinforcement, what is even reinforcement in construction, then the importance of reinforcement in construction, then the uses of this reinforcement that is being used in concrete in construction. So we'll take a look at the definition of reinforcement in construction. Reinforcement refers to the use of steel bar or mesh within concrete to improve its strength and performance. So the main idea here is, to improve its strength and the performance of the concrete, because concrete on its own can't, give you the desired strength. Reinforcement on its own can't give you the desired strength. So it is only when you make use of the both of them together in an appropriate ratio that will give you the desired strength. So concrete is strong in compression, you can see, but weak in tension, while steel provides the high tensile strength. So concrete is very strong in compression, whereby the steel, yeah, that is the reinforcement you are making use of, gives the tensile strength. So together they act as a composite material that resists various loads, prevents cracking, improves durability, and ensures safety and stability in structural elements. It is widely used in building bridges, foundations, slabs, beam, columns, and other concrete structures. So your reinforcement is used in your bridges, your beam, your column, your slab, all structural structures. So this is the definition for your reinforcement in construction. So we are going to be looking at the key reason why reinforcement is actually used. So why do we use reinforcement? So some of the reasons are here. The first one we have is increases strength. So because since concrete is good at compression, why steel is good at the tensile strength. So when you join them together as a composite material, it gives you that desired strength. So the first point here is it increases the strength of the concrete. The second point is it prevents cracking. Then the third point is improves ductility. Then the fourth point is increases durability. Mind you, ductility is different from durability. Then the next point is if cost effective, right? It actually helps your construction material to be of desired cost, which means it's economical. So we'll be taking a look at the first one, which is increases strength. So enhances tensile and flexural strength, right? So steel reinforcement compensate for concrete weakness in tension, because concrete is very good at compression. So you make use of steel to just compensate for the concrete's weakness in tension, so making structural elements stronger and able to withstand greater load. So in as much as you use your composite material, so you'll be able to withstand greater load. So the next point is prevents cracking. So control shrinkage and stress crack. So reinforcement holds the concrete together and limits crack formation caused by shrinkage, temperature change, and applied load. So we know temperature change usually cause cracking, shrinkage usually cause cracking, then applied load also cause cracking. So but in as much as you tend to make use of this composite material, which is your concrete and your reinforcement, so it actually gives you the desired strength, to be able to withstand shrinkage, to be able to withstand temperature change, and to be able to withstand the applied load, which acts upon the composite material itself, right? So the next point is improves ductility, so allows structure to absorb more energy. So when the load acts on the structure, so it actually helps the structure to absorb more energy. So reinforced concrete behave in a ductile manner, warning before failure and providing time to take action during extreme events like earthquake. So sometimes you see some of these cracks on the wall. It's like the building itself is giving you warning, for reinforcement or for maintenance or for you to use sealant and whatsoever, or for you to even pull down the structure. So, with the ductility of a thing, your building don't just collapse. It actually gives you warning for you to know that, okay, these are the certain things that are required of you to do for preventive measures, or for you to actually pull down the whole structure. So the next point is increases durability. So it improves long-term performance. Yeah, it actually helps to improve the long-term performance of the structure. Proper reinforcement design reduces cracks and deflection, which protects the structure from environmental deterioration and extends service life. So in quotes, is that service life we are even interested in, the structural integrity of the building and the service life. You understand? So if the building is going to be like maybe 10 to 15 years before, so because you have actually increased the tensile strength of the concrete, so the concrete tends to get more strength, right? So thereby increasing the service life of the structure. So the next point we're looking at is cost effective. So optimizes material usage and safety. So the use of reinforcement actually helps to optimize the material usage and also helps to provide safety. So efficient reinforcement design reduces overall material consumption while ensuring safety, reliability, and economic construction. So this put together actually helps to define, give the adequate reason why reinforcement is used in construction. So the first reason, as we've checked, is increasing strength, then provide cracking, improves ductility, increases durability, and it is cost effective. So we'll be taking a look at the uses. So area of use of reinforcement in construction. So building structures. So in your building structures, for your structural elements like your columns, your beams, your slabs, even your partition wall, and so on and so forth, you tend to make use of your reinforcement. Then for your foundation, which means your footing, your raft, your pile, your piers, your retaining walls, you also tend to make use of your reinforcement. Then for your bridges and flyovers, the deck of the bridge, the piers, the abutment, the barriers, so you tend to actually make use of your reinforcement. Then for the industrial structures like your warehouses, your factories, your chimneys, right, you still tend to make use of your reinforcement. Then water retaining structures like your tank, your reservoirs, your dam, your water treatment plant, you tend to make use of your reinforcement. Then for infrastructural works like your tunnels, your culverts, canals, your drainage systems, you also make use of your reinforcement. Then for your seismic resistant structure, which helps to improve earthquake performance and safety, you also tend to make use of your reinforcement. So from here we have a picture which actually depicts the usage of reinforcement. So we have the longitudinal bar, then we have the tie and the stirrups, then we have the cover block, then we have the concrete, then we have the foundation base. So this just gives a pictorial outlook of how reinforcement is used in your concrete. So reinforcement in construction is very, very important because it actually provides that tensile strength that your concrete needs. Because since concrete is already good in terms of compression, right, so we providing that tensile strength actually increases the overall strength of the concrete, thereby giving you the desired strength, which helps your structure to attain that structural integrity, to be able to carry the load that acts on the said structure.